This is my continuing coverage of Euclid Book 7 definitions, and what we're going to do today is we're going to show you the difference between what Euclid had in mind and what we have in mind. Now, the first thing we want to do is establish something, okay? In accounting, in statistics, and in data processing, a zero is an absence of value. This is absolutely true. If you're doing any of those things, you are to regard zero as an absence of value. Zero is never, in any case, a pretty little circle with a backward slash. Okay, that is something that's taught in elementary arithmetic, and you are way past that now. So get that out of your head. It's not just a pretty little circle with a slash through it. It is something. Now, zero can actually be a starting point on a number line. Okay? But, like I said, in accounting, data processing, and statistics, zero is the absence of value. In either case, whether you're talking about number lines or you're talking about statistics and etc., zero is never, ever, ever just a pretty little circle with a backslash. Never. So get that out of your head right now. Zero has something more meaningful than just a pretty circle with a backslash. And now that we've established that, let's go on to the difference between what Euclid was saying and what we're saying. Okay? What we're going to do is we're going to use a sliding number line. And remember, I was talking to you about, remember I was showing you the tape measure, okay? And we were going to actually talk about ticker tape. Ticker tape can actually be folded so as to illustrate a lot of our points. Now this is a unit of 2. Units are not just defined as 1. Okay, that's elementary arithmetic. Get that out of your head. Okay, so a unit is a unit, not necessarily a 1. You're always thinking it's a 1, but it's really a unit. Okay, and so therefore number sets can be thought of as units. Okay, you can have a number set and it's actually a unit. So let's get that. Oh, a unit is a 1. Not necessarily, because you've just now seen a unit. This is a unit of 2. This actually is 2 inches long, but it's considered as though it were 1 unit. Okay. So let's imagine this is a ticker tape that is just, this kind of stretches out here for an indefinite period, okay? Now we have your standard number line here. Now, if you put this between the 0 and the 2, you can find all your even numbers. 2, 4, 6, etc. But if you move this back just a pinch to the -1, you'll find your odd numbers. 1, 3, 5, and if we extended this out, it'd be 7, so on and so forth. So we can actually move your ticker tape back and forth and find the numbers that we're looking for. Alright. Now the next thing we need to explain is how Euclid defined even times even and even times odd. Now in the next video I will go into how he defined even times odd, but now I'm going to go into the part where he's defining even times even. Alright, Euclid says that an even times even number will produce an even number. Well, 2 times 2 is equal to 4. Well, 2 is an even number, 2 is an even number, 4 is an even number. But here comes the problem. You can say, well, how about 6 times 4? Well, 6 times 4 produces 24. 6 is an even number, 4 is an even number, 24 is an even number. Here's your problem. 8 times 3 also produces 24. So 8 times 3 is not a product of even times even. Why? Because the 3 here is an odd number. So every number has to be even. The 8 has to be even, the 3 would also have to be even, and the 24 would be even. And in this case it's not. So 24 is not the product of an even times even though 6 times 4 does make 24, and 6 is an even, 4 is an even, and 24 is an even. See what we're getting at here? Now, if you were to raise the number 2 to a power, okay, you were to raise the number 2 to an nth power, okay, now that n could be replaced with a 2, a 3, a 4, 5, it doesn't matter, it can be replaced with 126. Then you really will get even times even, okay? Because 2 times 2 is 4, 2 times 4 is 8, 2 times 8 is 16, okay? And so on and so forth. Because 2 times 2 times 2 is 8, and 8, of course, times 2 is 16. Alright? And that's where that comes from. So yes, raising 2 to a specific power will give you the formula for even times even. Now, we can actually talk about multiples at this point. Say multiples, yes. You can have a unit multiple. Okay? Now, when we say that 2 times 4 is 8, what we're saying is that there is two units. Okay? There's 2 of these 2 units in that. So this is a multiple of 2. Alright? And you can create a scale like this. Alright? And I'll go ahead and illustrate that here in just a second. Okay, so you can have 2 times 2, 2 times 4, and 2 times 8. And then you can have 4 times 2, 4 times 4, and 4 times 8. Okay. So actually, you're just moving this ticker tape down the scale with these multiples. Remember, this is a multiple here, and 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 so on and so forth. Okay? And that way you have unit multiples. Okay? Because you can have a unit of 2, or if you extend this out, you can have a unit of 4, or you can have a unit of 8. Okay? It's still one single unit, but it's 8 pieces within that unit. And that's what we're trying to get at here. And that's what's going to happen when we do the even times odd and the odd times odd. Alright? And so what you're doing is you're moving the ticker tape over a number line, and then it reveals all the answers you really need. Okay? And that's what we're getting at here. Whew. Anyway, in my next video I'm going to talk about even times odds and odd times odds and show you how to come up with all those numbers. Stay tuned.